Hello everyone, welcome to the Flying Machine channel. When we watch a fighter jet undergoing an engine check, we'll likely notice that the exhaust manifold is equipped with a nozzle that can open and close and move in various directions. Why is this? What is its function? That's thrust vectoring technology, which we'll discuss in this video. However, before we continue, let's support the Flying Machine channel by subscribing and turning on the notification bell. Thrust vectoring, also known as thrust vector control, is a capability embedded in aircraft to control the direction of thrust. The thrust vectoring device consists of a nozzle on the aircraft's engine exhaust manifold that can be moved in various directions. Initially, thrust vectoring was only used on rocket-powered spacecraft that glided beyond the vacuum of the atmosphere. In the vacuum of space, airflow-based flight control systems such as rudders, ailerons, and elevators cannot be used to change the aircraft's direction. The only device that can be used as a steering system for a rocket-powered aircraft in the vacuum of space is thrust vectoring. By controlling the direction of thrust generated by the engine, it generates momentum that can change the aircraft's flight direction. However, thrust vectoring technology is now also embedded in various fighter aircraft such as the Harrier jump jet, F-22 Raptor, and Sukhoi Su-35. To understand the effectiveness of using thrust vectoring on aircraft, let's first examine the concept of flight movements. Every aircraft, both commercial and military, can perform three types of flight movements along its axis of rotation: yaw, pitch, and roll. The first is yaw. Yaw is the aircraft's movement along its vertical axis, which involves turning to the left or right. This movement is controlled by the rudder located on the aircraft's tail. The second is pitch. Pitch is the aircraft's movement along its lateral axis, which involves climbing or descending. This movement is controlled by the elevator located on the aircraft's tail. The third is roll. Roll is the movement of an aircraft around its longitudinal axis, typically a rotating or rolling motion. This movement is controlled by the ailerons on the wings. In aerial combat, the ability to control these three flight movements is crucial for victory. This is where thrust vectoring comes into play. Fighter aircraft equipped with thrust vectoring are capable of extreme yaw, pitch, and roll movements, which are particularly useful in close-quarters air combat or dogfights, where agility in changing the aircraft's direction is crucial for victory. However, not all thrust vectoring systems on fighter aircraft are designed to control all three flight movements simultaneously. Instead, thrust vectoring systems are designed to meet the needs and other desired advantages. For comparison, the Sukhoi Su-35 fighter jet is equipped with 3D thrust vectoring to achieve superior maneuverability through extreme control of all three flight movements. Meanwhile, the F-22 Raptor is equipped with 2D thrust vectoring only for yaw and pitch. This was done to pursue another advantage, namely as a stealth fighter aircraft, by slightly reducing its maneuverability. Another advantage is that fighter jets equipped with thrust vectoring will have the ability to take off from short runways, known as short takeoff and landing, STOL. Furthermore, thrust vectoring devices on fighter jets like the Harrier jump jet and F-35 enable vertical takeoffs and landings, known as VTOL. This is thanks to the thrust vectoring device, which is designed to rotate up to a 90-degree angle, shifting the engine's thrust from being directed backward to pointing downward. This allows the aircraft to hover, much like a helicopter. To date, thrust vectoring technology has only been found on fighter jets and is not found on civilian or commercial aircraft, as these types of aircraft simply don't require it. That is the discussion about thrust vectoring on modern fighter aircraft. If you have any other interesting information on this topic, let's discuss it in the comments section. See you in the next video.